It's March 9, 2010. And ACM, which stands for Association for Computing Machinery, announces the winner of Turing Award, which many consider as the Nobel Prize in Computer Science. The award that carries a $250,000 prize, with financial support provided by Intel and Google, and it's awarded to a British-American computer scientist and computational theorist named Leslie Gabriel Valiant. So, who is Leslie Valiant, and why was he described by ACM as a heroic figure in theoretical computer science? And how did he address some of the deepest and unsolved problems in science? Born on March 28, 1949 in Budapest, Hungary, Valiant attended a few of the most prestigious schools and universities in the UK. He was educated at King's College, Cambridge, Imperial College London, and the University of Warwick, where he received a PhD in computer science in 1974. His profound insights in computer science, mathematics, and cognitive theory have been combined with other techniques to build modern forms of machine learning and communication, like IBM's A. Watson computing system, that have enabled computing systems to rival a human's ability to answer questions. While Valiant's most notable paper, A Theory of the Learnable, 1984, provided a mathematical foundation for describing how a computer could learn. In this paper, Valiant introduced the probably approximately correct PAC model, in which an algorithm posits a hypothesis based on some data set and applies that hypothesis to future data. The hypothesis will likely have some level of error, and the PAC model gives a framework for determining that level and thus how well the algorithm can learn. The PAC model has been greatly influential in artificial intelligence and in applications such as handwriting recognition and filtering unwanted emails. Valiant made key contributions to the theory of computational complexity. In 1979 he created a new class of complexity, hash P, in which a hash P problem is determining the number of solutions to an NP problem. He discovered the unexpected result that even though it can be very easy to determine whether certain problems have a solution, it can be extremely hard to determine the number of solutions. Valiant also wrote several papers about the theory of parallel computing, in which a problem is broken down into several parts that are worked on simultaneously by multiple processors. In a bridging model for parallel computation, 1990, he introduced the bulk synchronous parallel, BSP, model, in which individual processors communicate with each other only after finishing their computations. Each cycle of computation, communication, and then synchronization of the processors is called a superstep. Separating computation from communication avoids instances of deadlock, in which activity stops because each processor is waiting for data from another processor. The Turing Prize isn't the only prize he has won. He was also awarded the Van Prize in 1986. The NUST Prize in 1997, the EATCS Award in 2008 among others. Valiant is known by researchers the world over for his revolutionary contributions to theoretical computer science, said Michael D. Smith, Dean of Harvard's Faculty of Arts and Sciences, John H. Finley Jr., Professor of Engineering and Applied Sciences at Harvard University, both of whom are his peers at Harvard University, where Valiant is a professor now. Valiant has been teaching at Harvard since 1982, prior to which he was teaching at Carnegie Mellon University, the University of Leeds, and the University of Edinburgh. He currently resides in Cambridge, Massachusetts, in the United States of America. He has two sons, both of whom are also theoretical computer scientists. He is a Fellow of the Royal Society London and a member of the National Academy of Sciences USA, both of which are non-government, non-profit organizations of distinguished scholars.